talk is about building secure, reproducible data infrastructure with Nix and NixOS. So building data infrastructure is still surprisingly, I'm close to the mic, building data infrastructure is still surprisingly, to you I assume, manual. Us data engineers, we stitch together storage and catalogs and query engines with one-off scripts. And when we try to move that stack across environments, say from dev to a colo to a air-gapped lab, things break a lot. So with Nix and NixOS, it's possible to define everything as code and run the same stack and all its dependencies anywhere in a reproducible way. So that's the premise behind this talk. And before we define what a data lakehouse, not real estate here, is, I want to talk about what it isn't. So traditional data warehouses, databases, they're optimized for reliability and performance, but they're really rigid. So they require a lot of upfront data modeling. They rely on ETL pipelines to load data. They typically only scale vertically, which becomes really expensive and really complex when you have a large volume of data, which everybody wants to have. So data lakehouses took the opposite approach. So this was born in the era of Hadoop. These are store everything first data tools. They worry about structure later. So store it first, just the E of the ETL, put it all in, figure it out later. They scale horizontally. They're great for collecting a bunch of stuff all at once, but they're messy, they're disorganized. It's really hard to actually extract any information or value from. The combination, the game changer, is the two combined. So a data lakehouse brings all of the benefits from both types of data storage. It's built on object storage like a data lake, but it layers on transactional guarantees, ACID transactions, metadata management, all the things you expect from a warehouse. And the critical layer of this is the open table formats. So, and I'll explain what those are. But these support features like time travel and version control. These are things that make a data lakehouse functional. Okay, so I told you what it wasn't. So what is it? There's three main minimal components for a data lakehouse. The first is object storage. To work for large amounts of data, that object storage has to be optimized for scale and throughput. It has to be able to store structured, unstructured, semi-structured, all kinds of data. Anything from Parquet to logs to models. And then on top of that is open table format. So this is where I tell you what I told you in the last slide, but more in detail. So this is Apache Iceberg, Apache Hudi, Delta Lake. The OTFs are what introduces transactional semantics into object storage. It what takes the data lake, the database, and puts it in the data lake, making a data lake house. Okay, so it tracks data files, schema changes. This gives us really cool things like time travel, partition pruning, consistent multi-writer support. It's what makes it worthwhile as a data infrastructure. So the last part is compute. So this is your query engine, and this could be something like Trino or Dremio or DuckDB, depending on whether or not you need distributed execution or BI dashboards or fast local analytics. And the beauty of this architecture, the whole point of it, is that you can swap and drop. So your compute can be anything or it can be many things. But together, all of these three things is the minimal requirement for a data lakehouse. But if you're actually going to do it, if you're actually going to make a data lakehouse, you also need a catalog. So catalogs, anything but futzing around, need a catalog. So Iceberg catalog is where your actual metadata gets managed. It maps logical table names to metadata. So every time you write to a table, Iceberg will generate a new snapshot, and this snapshot references a manifest list, and which naturally points to manifest, which then points to the actual data files that are in Parquet. So it's a metadata tree. So the catalog stores the latest snapshot ID, the schema versions, the partition specs, the table properties. It's the get head pointer for your data. So this is what this is. So you can use a catalog for snapshot-based queries. So you can be like, select all the data as it existed in this specific point in time. You can do rollback. So if you mess up your data, which happens a lot, you can just roll back to the point when it was good. You can do branching, so you could do like a get like. It turns your data lakehouse into a get like system. So you can do branching. So you can have dev and prod. You can have, this is my futzing around space. This is Daniel, who always drops all his tables space, so on and so forth. You can do auditability. So metadata is appended. Auditability. So metadata is append only. Object storage is immutable. So you get a full history of all the changes that you have ever made. If you want to, you can decide what your snapshot retention will be. But that means you can. It's really important for fields where auditability is an important feature for enterprise data. Then so there's a couple. That's what it does. There's like 3 or 4 really good ones. They are open source. It's Nessie, Polaris, which is donated to the Apache Foundation by Snowflake. It's designed to be embedded, which is kind of a neat feature. Gravitino is really neat because it works pass and forward, so it works with things like Hive and stuff like that, but also with Delta Lake, Apache Iceberg. So you can go front and you can go back and it can go all around, and it's also an Apache project. So great. But if you're bridging legacy and modern, this is your guy for a catalog. So all 3 support REST APIs, which makes it really easy to plug into engines that I was talking about, those query engines like Trino and Spark and Dremio, and also, of course, object storage that also relies on REST. This whole stack is based on REST. So then you probably spend all that time explaining what it is. You're probably asking yourself, but why would I do that? So this is explained. It's a diagram showing where the lakehouse sits in an entire AI infrastructure. So the center data lakehouse is where everything lands: tabular data, training sets, vector embeddings, models, sensor logs. And I'm not trying to just repeat buzzwords. I'm just trying to explain why you'd want to build one, right? Your application data, it's your storage, it's your retrieval layer, it's everything. It's the heart of your stack. And then on the left, it's like your Hugging Face. It's where you manage your models, data sets, your collaborative spaces, all that stuff. It's where you can store and share and reuse models. And on the right, you have your ML ops stack. So this is the AI lifecycle in action, and data moves back and forth from this space as you make and create features, as you make and create models. And then you have a vector database. So those are the cool things like LanceDB and PineConeDB, and those are optimized for fast similarity search and powers RAG. And all of this is querying object storage directly without migration. So you can't have, it's the minimum viable requirement. If you want any of that stuff, you want all that stuff, you have to have a data lakehouse. Okay, so, and then of course, at the foundation, you have Nix, which declaratively defines and deploys all of it, right? From infrastructure to services to pipelines to security to the whole networking, everything, soup to nuts. That's where it is, ideally, Okay, so what, you're probably asking me right now, so what if I already have Docker or Podman or Kubernetes? Because I feel like I'm not tall enough for this, sorry. I don't think it's an either or situation. You can integrate Nix with into existing workloads. So in fact, you might need to do that because not everything is a Nix OS package yet, which is why you lovely people are here supporting the community. But many teams, data teams, particularly that's what I know about. We use Docker for deploying services and running analytics jobs already. So Nix can slot into those workflows and actually make it better. I've heard it said that Nix is a better Docker Compose than Docker, but I'll leave that to your interpretation. But you can use Nix to build container images reproducibly, and there's a couple of different ways to do that. You can use Docker tools.buildImage, and it lets you define the container and all of its dependencies entirely in Nix, or you can use Nix2 container to build OCI images and push them to a registry. But either way, you get fully versioned deterministic containers that behave in the same way in dev, in CI, and prod. And this makes Nix a great tool even in container-heavy environments, and you can use this to lock down builds and remove guesswork from your Docker pipeline. So you can have it all. But where does Nix actually fit in? So at its core, I mean, you might be familiar, but for those who aren't, Nix is a package manager. It builds software and systems with declarative specifications. So that means if your inputs don't change, your outputs don't either, not ever. So it should work wherever you put it. So with NixOS, that extends to an operating system, and you define your full system configuration in the file, things like services, user, firewall, rules, TLS certs, file systems. NixOS builds those all. So this is a real declarative infrastructure. There's no provisioning script, no bash, glue, no step 14 install JDK once again, over and over again. It's the same configuration builds your entire stack on your laptop, on your rack, on an edge box, wherever you want to put it. It's portable, reproducible, version controlled, and that's exactly what we want when we're designing critical infrastructure like data infrastructure. I giving this talk in part because I feel like data infrastructure is being left behind out of when we talk about critical infrastructure, but it is, as I said, in the heart of this stack. So just protect your data. So this is how essentially we move from fragile one-off setups to infrastructure that you can deploy like software. Okay, so a flake house. Flake house is a data lakehouse on Nix, right? So what exactly do you want to define in a Nix flake? So you want MinIO, which is, or whatever, your on-prem object storage software. You need Iceberg. That's your open table format. That's where your all the cool stuff about data lakehouse, time travel, evolution, partition. You need it. A catalog like Nessie or Gravitino or Polaris, so you get version control on your data. Trino, Spark, DuckDB for compute, the TLS, IAM, network policies. You need systemd to manage the whole thing. So the stack is entirely in Nix, or it could be. This is somewhat aspirational, which we will get into why or how the aspiration begins or becomes, right? All right, so, and then once the stack is defined in a flake, once your flake house is defined in a flake, we can deploy it anywhere. So it can go, like I said, on a laptop, in dev, edge, wherever. The point is, there's no manual tweaks, no drift, no reconfiguring. It just deploys like code. So this approach gives some really clear advantages. Obviously, security and control. So all your services, object storage, your catalog, your query engine, they should all deploy behind your trust boundary if you deploy it on-prem. And you have all your access control is defined for everything, every place you try to deploy this. This means you know it's running, who can talk to what, and how it was built. The operational simplicity is another point. So Nix OS modules make deployment and update consistent across environments, which is really important, especially since so many in data when so much is done locally. Data exploration, feature selection is often done on a laptop, but it needs to be extrapolated to a full data set, your full production system, and this can do that. It makes automation safer and onboarding safer. And then the third is scale and portability. So, like I was saying, you can deploy it from your laptop to your colo, and there's no drift. It's reproducible. It's scaling out becomes a matter of just replicating known good systems. So it makes your data infrastructure, predictable, testable, easier to move. So, but there's some challenges with this approach. So, the primary problem is that, or challenge, is that key components like Iceberg, Apache Iceberg, Nessie, Polaris, the catalogs, and Iceberg itself aren't available as Nix packages yet. So there's no official modules or system services for these components, which means you'd have to wrap them as binaries or run them as containers, or Docker, or whatever. But that breaks the full declarative integration, which is the cool part of what I was talking about. So, a tiny bummer. And then service orchestration. So there's really not a great way to express service dependencies across components. So, for example, ensuring that MinIO is online before the catalog initializes, or that Dremio doesn't start before the Iceberg tables are reachable. It has still manually scripted, so it's not. And then, defining the networking policy, defining encrypted communication across access control is possible. You can do it. But it's still a little fragile, especially with self-certs. It's a little pain point. And then it's secret management. So in object storage and MinIO and anything that's S3, you saw the whole stack. It's all S3 compatible. And the problem is that, or challenge, is that there's a tool called SOPS Nix that helps with integrating services that expect secrets as environmental vars, like S3 compatible anything. But it's a little inconsistent. So it would be cool if it was more less friction. So the foundation is really solid. The benefits are really clear. But there's room to grow, and I think primarily the room to grow, the where to grow, is to have Nix modules for Nessie, Polaris, Gravitino, and Apache Iceberg. And those are really foundational elements. You got 2 out of the 3 of the stack. Remember the 3 components of a data lakehouse: object storage, open table format, and query engine. Well, you got query engines because you got Spark and you got Dremio, and you got object storage, you got MinIO, but it's that middle bit. It's a little, So if you care about data infrastructure, or you just want to expand what Nix can do, this is your moment. And started the idea that building data infrastructure is still really fragile. It's stitched together with scripts and tribal knowledge, and it's just tuned for one environment, so it makes it really hard to move without breaking. So this is a really great alternative that Nix and NixOS offered to treat data infrastructure like code, where you can define your whole stack declaratively, version it, run it anywhere. And so if you're working on anything like this or want to, let's talk. Thank you.